Hey, me again. Today it's lesson 41, which is a prime number. It's a great number. I can't say I love being 41, but it's okay. Today we're going to be looking at finding rates of change and slope. So if that's what you're here for, then you're in the right place. Righty, let's get started. I do want to talk about some vocabulary today. I do think it's very important that you and I are using the same vocabulary. We're going to use the same dictionary as we talk. So as I use these words, they'll be in a math context, and so we need to be able to communicate with each other. So we'll be talking about some vocabulary, what things mean specifically. I'm going to draw you some pictures today as well, and we're going to take an idea that has a lot of applications to it in math and in life. Things are always changing, and we're seeing how two different things are related to one another and how they change sometimes over time, or as one thing changes, how the other thing changes. This is really a big concept in math. Even when you go all the way to calculus, which sounds really scary, really a lot of calculus is just finding rates of change of things. So what you learned today is going to be very applicable for your math career and getting things right in the lesson, but just is something that we'll continue to build on, and you'll see this idea come up over and over and over again in math. So let's get started, and let me go ahead and uh, talk about a little bit about vocabulary. I hope you can see this over there. Rate of change is the first thing. Rate of change is pretty straightforward. You can see if you're using your book that rate of change is a ratio that compares the change in one quantity with the change in the other. Ratio means that it's some sort of fraction, one thing compared to another. It's one thing divided by another thing. So an example of a rate of change would be taking velocity, your speed as you're going down the road. You look at a speedometer, you look at what mom's driving, you're like, Mom, the speed limit here is 55, you're going 92. If she went for an hour, 1 hour, and go 92 miles, that's a rate. Okay, and one thing depends on the other. Depending on how long you go at this rate, you'll go a certain number of miles. So rate of change again, you can read it out of the book or I can read it to you again. A ratio that compares the change in one quantity with the change in another. So velocity, acceleration, slope, there are all kinds of things. If you are running or if you have number of points per game, that's still a rate of change. Now, math has several different ways of doing this. We could just talk about it and describe how one thing changes from another. You can see also in the book that they've got some charts there where they list some specific things at certain points. For instance, the second example shows a table of renting kayaks, which I just did this last week. They gave us 3 hours for $15. So there's a rate of change. If every 3 hours that I go, I have to pay another $15, or for me it was 35. And so you could determine if I went for 6 hours, then that would cost me $70. And if I was kayaking for 9 hours, which I cannot imagine what that would feel like, then that would cost another $35 on top of that. That's a rate of change. If you're going bowling, price per game, or something like that. Or if you're going roller skating, okay, there's a charge there for the amount of time. Or price per donut. Okay, so if you can get 5 donuts, what's this going to cost you? Rate of change is all over the place. And miles per hour is a pretty simple one. Mathematically, though, they will also show it as a graph. Okay, and you need to know how to read a graph and interpret a graph and figure out what you need to know from a graph. So I'm just going to use the y-axis and the x-axis here for starters. I know there's going to be eventually there'll be quadrants and a whole grid there and whatnot. But for a lot of things, you know, we start at 0, we're going to go up. So I think you're used to seeing this thing before. And we're going to identify what's changing in which direction. So I think you know that this is the vertical direction and this is the horizontal direction. Horizontal direction will often be things like time, where you start at 0 and you always move forward. And one thing we're going to do is we're always going to read the graph from left to right. So I might draw the arrows, the lines a little bit differently than you may see in the book. I want to try to get that idea to you to always go from left to right as we go across the page. Also, we're going to pick out two different types of variables. Independent, spell correctly, dependent. That is, that one of these things is going to depend on what happens with the other one. So, for instance, donuts and then the cost. Well, it depends on how many donuts you consume as to how much that's going to cost. So the amount of donuts is the independent variable and the cost is the dependent variable. You have to be able to determine in a problem which thing goes on which axis. It's very important for you to determine the slope correctly. So x is typically the independent variable and y is the dependent, but you can put anything in there. You can have time and distance on there as long as they're in the right place. You have to determine that. Another thing that I try to stay away from is using the expression rise over run. I've always found that very confusing for people, especially on the rise part. Usually people get the left to right thing correct, but they don't know what to do about it, especially if your graph goes down. And I mean a word like rise when the graph is going down doesn't make sense, so people are always trying to go up because that's rising. So I'm not going to use that. I'm not going to use that anymore. I'm going to stick with some of the notation that you'll see later on in math, and that's much more applicable. And that would be using a triangle. And a triangle means change. Okay? Change. And what I'm going to do is I'm going to say the change in the y variable or the dependent variable compared to the change in the x variable. And right there, that is a good definition or rate of change. Okay? Change in the y variable or the dependent on top and the independent variable on the bottom. Rate of change. Okay, it's very applicable to lots of different areas. So in a sense, it's like we come over here and we're looking at it and we say, where did this thing start? And then where did it finish? But I'm only going to look at how much it changed, like I'm looking at it from this side. And then on the X, I'm going to look at where it starts and where it finishes. And I'm only going to look at it from like underneath and see how far that it goes in that direction. That'll determine our rate of change. Well, let me define these two bits here for you. And typically, you're going to have data, like in the problem with cost and time. They've got some data points there where they'll say, this is a certain amount of time and a cost, and here's another certain amount of time and a cost, and we need to figure out what's the pattern, what's going on there. So we're going to define a change in y as the second y point, and then we're going to take away the first y point. That tells us how much it's changed. We go, well, it's here now, and it was here, so that means that it's changed that much. And then we're going to do the same thing on the x side of things. We take the x2 minus the x1. This right here is the slope formula. It's just a different version of delta y over delta x. Change in y and change in x. So change in y is the second y minus the first y, and change in x is x2 minus x1. So I'm going to put in there that is also equal to, or the formula for finding the slope. So let me take, for example, some information off of example 2 in the book. We have in one place time of 2 hours and a cost of $32.50. That's like these two data points right here. Okay? And in the picture, they've got a change in time is your x value. So they're saying that at the 2 hour point, I'm looking at $32.50. And I'm going to pick any other of those points there, and I'll pick just the next one at 4 hours. That'd be time 2. And then at time 2, the cost has now become $60.50. And really then, if you do the math on the top and on the bottom, you'll find what that rate of change is in cost per hour. Cost per hour. You have to keep track of what those units happen to be. So there's some pretty straightforward math. There's a difference of $28. And here we have a difference of 2 hours. So we do the math there, we'll get a rate of change of $14 per hour, which sounds like that makes sense. Okay, so just quickly in review, what we're dealing with here is a concept that's going to just keep coming up as we look at pictures of things, as maybe we look at a table of information, or we look at something that's just given as a sentence, okay, as it's given like a word problem. And from that, we're supposed to figure out some things about what's going on as things change. Now, the next little bit I'm going to do picture-wise, so I'm going to clean up my board here and then just cover 2 last concepts and we'll be done for today. Right. So our last 2 concepts are going to be when is that slope a positive slope and when is that slope a negative? And then what happens if you got a line that doesn't ever increase or a line that is just going straight up. So we want to talk about those 4 things in the next 2.5 minutes. So I think you're probably, if you did the previous course, you're familiar with slope being positive or negative. And here's my little trick here. So if you've got a positive slope, it goes like this. And usually we draw an arrow going both directions, but for today I'm going to draw the arrow like this to represent this line so that you're reading it from left to right. Okay, you see how I did that? Got an arrow tip there and we got an arrow tip there. This is a positive slope. If I'm going to do a negative slope, it's going to go this way. Okay, so that's how we identify it. If I'm going downhill from left to right, negative slope. I'm going uphill from left to right, I'm going a positive slope. Because the y is decreasing as the x is increasing. And here the y is increasing as the x is increasing as well. X always increases, and then we look at what's happening with the y part. The other bit would be, what do we do when we have a horizontal or a vertical line? Well, a horizontal line like this is just going to be a y equals and then some number or some constant k. Like y equals, this might be y equals 2. There's no x involved in the equation at all. That's a horizontal line. As x changes, y doesn't change. That would be as maybe x changes by 5, but y doesn't change at all. I am allowed to do that math right there. But if it's a vertical line, I don't even know how to draw that. I just draw it with this. This is an x equals a constant. Like maybe this is where x equals 2. Okay, and this has no definable slope. X is not increasing, but y is increasing a whole bunch. Let's say y increases by 5, but x doesn't increase. This is called having a slope that's undefined. There's no way to say how that one thing is changing in terms of the other because the x is not changing at all. And that's the independent thing. That's the thing that we plug in to see how the other thing changes. So you're allowed to put that null set on your homework for those where you get a vertical line and x equals line. Well, that's all for today. We'll see you again tomorrow.